The objective for this lesson is to be able to write and evaluate logarithmic expressions. Logs is something that up to this point you probably haven't seen before, so we're going to take a look at those. We've been looking at exponential functions, y equals b raised to the x power. This exponential function is a 1-to-1, so its inverse would be x equals b raised to the y power. To express y as a function of x for the inverse, we write it as what you see here, y equals log with the base b of x. Once again, that's read as log base b of x equals y. If b is greater than 0 and b is not equal to 1, then this equation is true if and only if b raised to the y power equals x. So one more time, you would read this as y equals log base b of x. So what I want to do now is look at rewriting exponential equations in logarithmic form. So here we have 100 equals 10 raised to the second power. This 10 here is my base. If we look at it, once again we have x equals b raised to the y power, then log of base b, or log base b of x equals y. So the way that I would rewrite that is I take the 10, it's my base, so I put log of base 10 of the 100, what it's equal to, equals the little exponent, it equals the 2. Now the reason that we use logarithms is to help us find that exponent. So we're taking the base and plugging it in, taking what it is equal to, plugging it in, and then that's allowing us to solve for that exponent of 2. So let's look at some more. 81 equals 3 raised to the fourth power. Now I did some color coding here so you can kind of see where what goes. 81 is in the place of my x. So it's also in place of my x over here in this equation. So x here, that would be this x. The b is my 3, and it's the base over here in the log function. So when I write it out, I have log base 3 of 81 equals 4. It allowed me to solve for that exponent of 4. Let's try another one. You can just kind of ignore my little chicken scratch over here on the side. But we have 8 equals 2 raised to the x power. Once again, x equals b raised to the y. Now that gets a little bit confusing because up here it's an x and here it's a y. But don't pay attention to the letters, just look at the place of where things are. So in place of my x is 8. So over here in place of my x I want to put 8. Here I've got the 2, that's in place of my base b, so down here I want to put a 2. Okay, and then my little exponent is in the same place as my y, so my exponent is going to go out here. So when I write it out, I have log base 2 of 8 equals x. So what we can do is you can use the graphing calculator. If you hit the math button, let's walk through these steps together. Hit math. I hit the up button instead of down. You can go all the way down to b, but it's shorter if you go up to log base. Hit enter, and it gives me the formula to type in. So if you look back at where we just were, we had log base 2 of 8. So I want to type those numbers in. Log base 2 of 8 equals 3. And of course we know that one. That one's a simple one. 2 raised to the third power is 8. So log base 2 of 8 equals 3. Let's rewrite 6 squared equals 36 using the logarithmic form. So I have log base 6 of 36 equals 2. Try this one. 8 over 27 equals 2/3 raised to the third power. You might want to pause it. Give yourself a second to try this. The answer is log base 2/3 of 8 over 27 equals 3. Okay, try this one. 1 equals 3 raised to the 0 power. Rewrite this exponential equation in logarithmic form. Once again, you might want to pause. Log 3 of 1 equals 0. Log base 8 of 32 equals x. Solve for x. You're probably going to want to go to your graphing calculator. I'm just going to hit second enter and then evaluate. It was log base 8. So I'm going to change that 2 to an 8 because it was log base 8 of 32 equals 1.6 repeating. I don't want my answer in that, so I'm going to convert it to a fraction. So hit math, change the answer to a fraction, enter, and it is 5 over 3. So x equals 5 over 3. Now, what I did here was I showed you a way, if you don't have a graphing calculator, to do this by hand. We know that 32 is the same as 2 raised to the 5th power, and we know that 8 is the same as 2 raised to the 3rd power. Now, previously this year, we learned that a power raised to a power, we multiply those. So I know if they both have base 2, this one's raised to the 5th, that this has to be equal to 5. So 5 is equal to 3 times x. I divide both sides by 3. That becomes 1. 5 divided by 3, or just 5/3, is equal to x. Okay, go ahead and take a minute to try these 3 problems. You can pause it. Go ahead and use your graphing calculator or do it by hand. It's up to you, whichever you prefer. After you get done trying them, then you can unpause the video, and here are your answers. Okay. Now I'm going to read you a problem using the Richter scale. This is an application problem. It says, in December 2004, an earthquake with a magnitude of 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. So in December 2004, it was 9.3 on the Richter scale. In March 2005, it was 8.7 on the Richter scale. You can see I put these scores on here for you. Okay. There is a formula. Log I sub 1 over I sub 2 is equal to magnitude 1 minus magnitude 2. And this compares the intensity levels of earthquakes. And these I's show the intensity level. So what I want to do is I want to plug it in. The magnitude is 9.3 of the first one. The second one is 8.7, so I'm going to subtract those two, and I get a difference of 0.6. So I have log of the intensity levels, that I don't know what those are, equals 0.6. Now, before I go any further, I want to explain something. Common logarithm is logarithms with a base of 10. I forgot to mention this to you. When we write the square root of x, I don't typically write the little 2 out there. I understand that this is saying the square root of x. But if I did write that little 2 out there, these are the exact same thing. Well, in the logarithmic system, the common logarithm is a logarithm with the base of 10. So oftentimes you're going to see just log x. There's not going to be a little b written here. There won't be a base. Anytime you see just log of x, it's understood that the base is 10. Just like when you see the square root of x, it's understood that there's that little 2 out there, that we're taking the square root. So I just want to keep that in mind. So in this problem, in the formula down here, there is no base. But the Richter scale is based off of a logarithm with base 10. So that's why they have this intensity measurement. Log of the intensity level equals the magnitude of the first minus the magnitude of the second. So when I take the difference, I get 0.6. So at this point, you can look at it as log base 10. I'm going to rewrite it. Log base 10 raised to the 0.6 power equals I1, the intensity level of the first, divided by the intensity level of the second. That's going to, this intensity level of the first divided by the intensity level of the second is going to give me the difference in the strength. It's going to tell me how many more times intense, or the intensity level of the first one compared to the second one. Okay, so what is 10 raised to the 0.6 power? You can go back over here to our calculator and look at this. 10 raised to 0.6. Oops, I typed 11, didn't I? My bad. Ten raised to the 0.6 power is approximately 3.98, so it's 4. So I know that the intensity level of the December earthquake was about 4 times as strong as the one in March. Looking at these right here, 9.3, these scores, I guess that you would call it, the intensity level of the earthquake, or the magnitude, I mean, of the earthquake, you wouldn't think that 1 is 4 times. Clearly, 8.7 times 4 is not 9.3. But that just goes to show you that the logarithmic scale is different than what we're typically used to looking at. So from a 9.3 to an 8.7, the December one was 4 times stronger than that March one. So that's an application problem to use logarithms.